Hello, my name is Patrick Bryan, and welcome to Physics 2, Lab 1, Charged Tape. The purpose of this lab was to observe the polarization of two insulars, then to create a computational model of one insulator experiencing gravitational and electric force at equilibrium, then compare this computational model to the observational model, and finally to understand the effect polarization can have on insulated materials. The main physics principle of this lab is electrical polarization, which is simply the separation of positive and negative charges in a material. The equations used in this lab were the force of gravity, Fg equals mg, electric field, E equals the electric constant, Q over r squared, and electric force, which is F equals QE. Here's a preview of my results. Models. First, there is the observational model, which was made via experimental analysis, recorded through photos and qualitative analysis, with the only quantitative measurements being the length and mass of the tape, as well as the distance between the two pieces of tape as they were separated. For the computational model, that was made with GlowScript code, assumed the insulator is polarized, obviously, and it predicted the forces applied to the charged tape as it floated midair. Experiment. Recording, I photographed the polarized tape with and without hand near to show that the tape was polarized. For computations, we had the tape length at 0.2 meters, the distance between tapes at 0.0024 meters, the mass of the tape being 0.0002 kilograms, and G, the gravitational constant, as negative 9.8. Computation model, once again, created in GlowScript to show the forces at equilibrium as the charged tapes repelled each other. Here are the experimental photos. Here is the tape that was polarized on my desk. This is it with my hand near. You can see that it slightly moved forwards as it was attracted to my hand. For the code for the electric diagram model, as you can see, we first laid out all the variables. We had a scalar just for the vectors to show up properly on the diagram. We get the size of the atom, tape length, tape width, to find the tape area, and then to find the number of atoms on the tape area. Force initialization for force of gravity. Then you can equate, since it's at equilibrium, the electrical force to the force of gravity. Simply solve for Q by rearranging the electrical force equation, and this was just to put the spheres of each tape as point particles on the diagram, and then finally to find the electron ratio of electrons lost to number of atoms, which was then shown here. Once again, these are the results for this experiment. And discussion. Why? It is important to handle charged tapes as little as possible because when another charged object, like a hand, comes in contact with the polarized tape, it introduces new charges into the system. These charges then depolarize the tape, making it no longer react to other charged stimuli. And what if? If the charges of electrons and protons were reversed, then on a select few interactions, it would change with the charged tape. As the tape is proton filled, it would attract positively charged objects like a glass rod in this scenario. However, when in proximity to a hand, it would still be attracted as a hand contains both negative and positive charges. Similarly, two U tapes would repel as they have the same charge. Conclusion. This lab showcased the effect and importance of electric polarization and how it can influence various real-world systems, such as electronics and mechanical technology. Thank you for watching.